Picture a world untouched by time, some 7,000 years ago, where a lone hunter crouched in the shadows of a cool Iberian cave. His skin was darkened by the sun, his hair as black as the night, but his eyes, oh his eyes, glowed a striking blue, like twin fragments of a forgotten sky. This wanderer, one of the last of his kind, carried a secret in his DNA, a rare spark that would light the way for millions. Who was he? How did those vivid blue eyes come to be? To find out, let's journey back to a time when the world was wild and humanity lived by the rhythm of the seasons. This man, whom scientists later called La Brana, was no king or hero of legend. He was a forager, tracking deer through dense forests, fishing in shallow streams, and crafting tools from stone and bone. His people, hunter-gatherers of the Mesolithic era, knew the land by its scents and sounds, not by maps or borders. Yet within his genes lay a tiny change, a mutation so subtle it went unnoticed in his lifetime, but would echo through the ages. His blue eyes, a rarity in a world of brown, were the first whispers of a genetic revolution. Let's unravel the science behind those eyes. Eye color comes down to melanin, the same pigment that shades your skin and hair. In the iris, that delicate ring around your pupil, more melanin means deep brown eyes, while less reveals blue. But blue eyes aren't truly blue. They're an illusion, a trick of light. When sunlight enters an iris with little melanin, it scatters, reflecting shorter blue wavelengths, much like the sky on a clear day. It's not pigment, but physics that paints those eyes blue. This optical magic hinges on a single gene called HERK2, which acts like a master switch. It controls another gene, OCA2, responsible for producing melanin in the iris. Thousands of years ago, a small tweak in HERK2 turned down the dial on OCA2, reducing melanin just enough to unveil blue eyes. This mutation is recessive. You need one copy from each parent for blue eyes to appear. A single copy often leaves eyes brown, but when both parents pass on the altered gene, the iris transforms, revealing that ethereal blue. Now let's travel further back, to a time some 6,500 to 9,500 years ago, when the Ice Age had loosened its grip on Europe. The glaciers had retreated, leaving behind a lush, green continent teeming with life. In what is now Ukraine or southern Russia, near the northern shores of the Black Sea, a single human was born with this genetic quirk. Among a small band of hunter-gatherers, this person, whose name is lost to time, gazed out with the first blue eyes in human history. The mutation, known as RS12913832, didn't change their survival or strength, but it made them stand out. A single spark in one person's DNA, and every blue-eyed soul today carries its legacy. This wasn't a trait that evolved in multiple places. It happened once, in one individual, and spread from there. Imagine those early hunter-gatherers moving along rivers, hunting boar, and gathering berries under a pale sun. Their lives were raw and fleeting, yet one of them carried a trait that would endure for millennia. Scientists were stunned when they found traces of this mutation in ancient bones. In that Iberian cave, La Brana's DNA revealed he had dark skin and black hair, yet those piercing blue eyes. His discovery shattered old ideas that blue eyes were tied only to light-skinned farmers who came later. Far to the north, in Motala, Sweden, another group of hunter-gatherers, living 7,700 years ago, told a similar story. Their bones, too, carried the blue eye mutation, but their skin was lighter. This was a revelation. Blue eyes and light skin didn't evolve together. Instead, they merged later, as people migrated and mingled across Europe's vast forests and plains. DNA studies show a dynamic world of movement, where small bands traded tools, shared stories, and passed on their genes. So why did blue eyes spread? In the dim light of post-Ice Age Europe, lighter skin may have helped absorb more vitamin D, a slight edge in survival. But blue eyes offered no such advantage. Their rise likely came from other forces. In small, tight-knit groups, a rare trait like blue eyes would have turned heads, perhaps making their carriers more desirable as mates, a process called sexual selection. Or maybe it was chance. When small bands with the mutation settled in isolated pockets, cut off by mountains or rivers, their traits became more common, a phenomenon known as the founder effect. Over time, this single gene drifted across Europe, carried not by conquest, but by human connection, attraction, and luck. Today, blue eyes are a hallmark of certain regions, especially around the Baltic Sea, where they form what some call the blue eye belt. In Estonia, nearly 90% of people have blue or gray eyes. In Finland, about 85%. In Sweden, 78%. In Lithuania and Latvia, over 75%. These areas, once home to isolated populations, preserve the mutation through limited mixing. In Denmark, over 60% have blue eyes, while in Germany, the figure ranges from 40% to 60%. In the British Isles, blue eyes shine in about 50% of Irish, 48% of Scots, and 30 to 40% of English. But as you move south, the trait grows rarer. In Spain, only 16% have blue eyes. In Italy, 14%. In Greece, fewer than 10%. This reflects ancient migrations, as Neolithic farmers from the Near East and later empires from North Africa and the Middle East brought dominant brown-eye genes. Beyond Europe, blue eyes are scarce but not absent. In parts of Afghanistan and northern Pakistan, they appear in small pockets, likely from ancient Indo-European wanderers. Among some Ashkenazi Jewish communities, blue eyes reflect European ancestry, while in North Africa, among Berber and Tuareg peoples, they hint at historical ties to Europe. Global migration has carried this gene to every corner of the world. In the United States, about 27% of people have blue eyes, down from nearly 50% a century ago. In Australia and Canada, the trait remains common among those of Northern European descent. In South America, South Africa, and parts of the Middle East, blue eyes flicker in mixed populations, a testament to humanity's endless movement. These blue eyes are more than a color. They're a thread in the tapestry of human history. A single mutation, born in one person thousands of years ago, has woven its way through time, connecting us to a forgotten hunter who walked the wilds of a lost world. It's a story of chance, beauty, and resilience, written in the DNA we carry today. If this glimpse into our past has sparked your curiosity, keep exploring the genetic tales of humanity. From the ancient migrations that shaped the Irish to the intricate ancestry of Italians, Greeks, Germans, Basques, and Scots, every people has a story etched in their genes. Dive into these narratives. They reveal the journeys that made us who we are, one mutation at a time. Subscribe to Past Unveiled for more videos like these, where history's forgotten chapters come back to life.